So even though we've probably had this before, it's important for us to understand that we've got to solve equations correctly, because the majority of everything we do is wrapped around our ability to solve equations in Algebra 1. So at the end of this lesson, you'll be able to say, hey, I can solve an equation. Now, I've given you just a couple of examples to start out with. There are lots of ways to solve equations. It's just not just one way. You know, a lot of textbooks will tell you right at the very beginning that there is a method called the guess and check. Well, if I took x minus 6 equals 4, there's my equation, and I do the guess and check method, and I start guessing at what might x be. Well, x might be 9, so 9 minus 6 is 3. Nope, that's not the answer. So I might guess that the answer is 10. X minus 6, so 10 minus 6 is 4. Yeah, that's the answer. The guess and check method is not very mathematical, and if our equation was much more difficult, then it would not serve us very well at all. Or we could talk about working backwards. I've taken some number and I've subtracted 6 from it and I get 4. So if I take 4 and I add 6 back to it to go backwards, I arrive at 10. And that's a pretty mathematical approach. But really, in order for us to solve it in the most mathematical way, the most algebraic way on our journey to the truth, we probably need to use properties. You know, we've talked about a lot of properties so far in earlier lessons, and I want to kind of just let you look at a chart briefly of 4 additional properties, and these properties are properties I believe you'll understand immediately. In order to really algebraically solve 1- and 2-step equations, we need to use the properties of equality. Now, you'll find that chart in your notes, and you don't have to write every one of those down. But just to kind of summarize it, we can use the properties of equality to solve for a variable. Here's what we know. We know that there's a property called the addition property of equality, meaning that if we add the same value to both sides of an equation, that equation remains still equal. You know, here it is in numbers. If I have 3 equals 3 and I add 2 to both sides, it's still 5 is still equal to 5. Just because I added 2, I added the same amount, so they're still equal. Algebraically, we might write it this way. A equals some number B, and if I add C to both sides, it's still equal. Well, similarly, the subtraction property of equality is very much the same. If I subtract the same amount from both sides, they're still equal. Or if I multiply the same amount to both sides, they're still equal. Or if I divide both sides by the same amount, they're still equal. So let's look at some examples using properties to solve equations. So write this first one down, please. And I'm actually going to call this example number 3 because I talked about those first 2. Three x minus 2 equals 6. Remember, our equal sign forms sort of a border. We have each side of the equal sign. And our properties tell us if we do something to one side of the equation, we must do the same operation to the other side by the same value. Now I want to point out something I've seen some of you miss. This says to subtract 2. It also means a negative 2. In a way, they're sort of interchangeable in the way that we're going to look at it. Now, if I were to solve this equation, the first thing I would like to do is eliminate any addition or subtraction in the equation first. And then I'm going to deal with any multiplication or division. Prior to doing that, I would simplify anything that I could. But when I go to solve the equation, it's sort of in the same order that I learned. I learned to add and subtract before I learned to multiply and divide. So I would like to get rid of this subtraction of 2, and I'm going to do so using the addition property of equality. So in other words, I'm using properties to solve equations. That's how I solve an equation. So I'm going to add 2 to both sides. Write that down. And when I do, 6 plus 2 has a value of 8. And I know that negative 2 plus 2, or the subtraction of 2 and add 2, those are 0. They cancel each other out because they're opposites. You know, if you may remember, we called that the inverse property of addition. Inverses give us 0. Now I could write plus 0, could write 3x plus 0 here. But it really is not necessary to write that, because anything plus 0 is just it. That's the identity property as well of addition. So I'm just going to bring down my 3x. And remember that it's equal to 8 because I added the same thing to both sides. Next, I'll use the division property of equality, because I have 3 times x, and I'd like to be rid of anything, any number around the variable. So I want to isolate that variable so it's by itself. So this is 3 times x, therefore I'll just divide both sides by 3. When I do that, the 3's cancel each other out. 3 divided by 3 is 1. So I'm left with 1x. But I really don't have to write the 1. I can just write it as x because they're the same thing. 8 divided by 3. Well, I could go and make that a mixed number. In elementary school, maybe even middle school, we'd have done that. I could divide that and get a decimal number, but for us in algebra, we just want to leave that as an improper fraction. That's my answer. Let's look at another example. If you're watching the video, after I write the example down, I suggest you pause the video, work the problem, and then unpause it. So the problem now is 5x minus 10 equals 20. So let's look at the solution of this problem. Well, the first thing I want to do is remember that the equal sign forms sort of a border, if you would. And I want to get rid of the subtraction of 10 using the addition property of equality. So I add 10 to both sides. (20 plus 10 is 30. I know that a negative 10, a positive 10, those two are subtract 10, add 10 to it. Those are going to cancel each other out. which is kind of what I want to have happen. And I'll bring down my 5x. Using the division property of equality, I'll divide both sides by 5. 5 divided by 5 is just x. Again, just like I didn't have to write 5x plus 0, I'm not going to write 1x. And 30 divided by 5 is 6. So my answer is x equals 6. Now, there are other times, other books, other ways to write it. I mean, I could have written it this way. I could have said 5x minus 10 equals 20. And I can add the 10 here as well. It doesn't have to be up and down. And that's if I had the right thing. I can add 10 here as well. And my solution will still be the same. It'll be 5x equals 30, or x equals 6 when I divide. I don't care how you write it on the page as long as you know what you're doing. Let's look at another problem. Please write this one down. One half z plus 4 equals 10. So algebraically speaking, personally, I prefer, and this is just me thinking, when it comes to 1/2 times z, I would rather write that this way. I'd rather write it as z over 2. Now I can do that if you remember, I can write any number over 1 to write as a fraction. In other words, I can write z as z over 1. That doesn't change that value. All numbers can be written as a fraction over 1. And if I multiply that out, 1 times z is z in the numerator, 2 times 1 is 2 in the denominator. So I can convert those fractions that way. And personally, when I'm doing math or the algebra that I'm doing, I'd prefer to look at it like that. Z over 2 plus 4 equals 10. What I want you to understand is these two equations are identical. They've just been written a little differently. So again, the border here is the equal sign. And I know I need to deal with addition or subtraction first and eliminating that from my equation so I can get to the variable. So my first step will be using the subtraction property. Is to subtract 4 from both sides. Well, positive 4 minus 4 is 0. And I'm left with z over 2, or z divided by 2. I don't have to put plus 0, so I'm not. 10 minus 4 is 6. So I'm left with z over 2 equals 6. Since I have division, I would like to do the opposite operation as I've done every time, and I'll use the multiplication property of equality to multiply both sides by 2. This is z divided by 2. So I'll multiply by 2. Here's basically what's going on. Kind of like our dimensional analysis, remember 2 can be written as 2 over 1. And I'm multiplying it times z over 2. And you remember in dimensional analysis, I canceled my units from numerator to denominator. I can do the same thing with just integers or numbers, real numbers. So these will cancel. And my final solution will be that z is equal to 6 times 2, which is 12. So here's one for you to try, and I'll go ahead and write it down, and then you can pause the video if you're watching the video. Work it on your own, come back, and then check and see if you've got it correct. It's 1/3 x plus 9 equals 21. So if you're watching the video, pause it, write down the problem, and come back and see if you got it correct. Let's see how to work this problem. Just like before, the equal sign serves as our border, if you would. And I will always deal with subtraction and addition before I deal with multiplication and division after I get it simplified to this 2-step equation. So I have addition of 9. I'll use a subtraction property to subtract 9 from both sides. Just like that. Plus 9 minus 9 is 0, and I'm not going to write down 1/3 x plus 0. Now remember, I like to write 1/3 x as x over 3. So I'm going to make that change or substitution. 21 minus 9 is 12. Now use the multiplication property of equality to multiply both sides by 3. This will cancel, leaving me 1x. So x is equal to 12 times 3, or 36. Any questions? So using those properties, it's a much easier way to solve equations versus other methods like guess and check or working backwards. We want to just use those properties of equality to solve those equations. You'll have some homework on that tonight.